in this exercise we are going to make a Minecraft Legends style character. So that's basically a character that has a bit more expressive animation. So there's a bit more complicated armature rig, but it's also going to have Toon style outline shading. So let's create our character. So we've got the head. To make this easier, what we can do, view sidebar, just so that we can see the dimensions of our object. So we've got dimensions and scale. So what we're going to do is go into scene properties. I'm going to change the units. So click on that, and if we watch what happens to the dimensions of our cube when we change unit scale, increase that to 4, we've now got a cube that is 8 by 8 by 8, and that is the size of the Minecraft character's head, 8 units by 8 units by 8 units. So this is just a quick tip or a quick way to keep everything in scale with Blender, and obviously we can change this back when we want to. Just select the type 1 and it's back to normal. Let's go with 4 for now. And this just keeps everything relative to Blender's default scale. That's the important takeaway from this. Right, so that's the head. I'm just going to move that. So let's just check which way we're facing. So view, viewpoint, front. So numpad 1. So that's the front, so we'll just move that up. Just duplicate this object, duplicate objects, so Shift D, again that's a shortcut. Escape to reset, just move that to one side, hold Control to snap to the grid. Object, duplicate again, escape, that will be the torso. Escape, and this will be the leg. So those are our 4 basic elements. So we want to scale these relative to how big they should be for the avatar. So click drag just to go back into 3D view. So the head 8 by 8 by 8, the arms and the legs, dimensions of those are 4 by 4 by 12. The torso is 4 by 8 by 12. So let's do the arms, or arm, as we've only got one. We'll use the dimensions in the sidebar. So select type 4, select type 4, select type 12. Same for the legs, 4, 12, then the torso. That's the wrong dimension, so undo that. 12. Those are our basic elements. View, front. Let's just position these where they need to be. So the leg, hold Control, snap to the grid. Hold Control, snap to the grid. Those are our character basics. So before we go any further, let's just save the file. File, save as. Legacy 1. Save. Just going to go quickly into, well, there are 2 ways that we can do this. Either in Object Properties, we can go into Viewport Display and enable wireframe. We can do this on individual objects. Let's just deselect that so that's visible. So there's the wireframe around our object. Or we can go into Overlays and enable wireframe globally. That applies to everything. So we can do it individually, per object, or globally for the entire scene. So those are the basic elements of our character. Next, materials. There's a default material assigned to these already, which we can use, but if the objects didn't have one, we could click on the plus button and then the new button to create an instance that would then be populated with these properties. But as we've got one, we can use that. So let's just call it Legacy. There's our preview. We can change the color if we want, just for now the base color. That won't be visible in solid mode, but it will be in material preview. So that's our material basics. To complete the material, we want to go into shading workspace. There's our character. And this is why viewport overlays and the wireframe option is useful, because this scene by default isn't set up to use wireframe. So we can just go into overlays and just enable it globally, and it applies to everything. So there is our basic material. So the two nodes that we've got, principled BSDF and material output. So to this we want to add texture, image texture. And this will allow us to reference an image that will appear on the mesh. So we can do that by clicking open and loading in something that we may already have. That loads in our image. Then to see it, link color, so click drag to base color. And there we can see the image, albeit blurry at the moment, assigned to our object. So to fix that, the blurriness, what we want is that Minecraft blockiness. What we want to do is go into material properties, expand the base color options, and here we want to change linear. Click on the entry, and we want closest. And if we do that, watch what happens to the image. It properly pixelates, so it removes the aliasing that Blender applies automatically because it assumes that's what you want. But we don't want that in this case. And that's all we need to do for the material. So we go into our material properties, expand base color options, and then change linear to closest. So that's linear, that's closest. Let's get a bit closer on that. So linear, that's the default, closest. That's all we need to do for the material. Let's save the file. So we've got a restore point to go back to. And then we can UV unwrap. So that's all we really need to do for the material. It's just load in an image and link that up so that it appears on our object. Let's just reduce specular so that we can see the image. It's a flat image. So that is our material. So now that we've got this, we can use it to UV unwrap our objects. So UV editing. This is the default, so we're in solid mode. We want to change that, so click drag the header. Want to change that so that we're in material preview. And there is our teeny tiny image, so it's 64 by 32 pixels. And by default, Blender auto selects the last or the active object and selects all the faces so that we can see the default UV map that was assigned to the cube. So if we didn't have a UV map, all we'd need to do is go into the UV menu in 3D view or the UV editor and select Unwrap, Unwrap, and that would generate an initial UV map that would look something like this. But we're not going to use this, we're going to modify this, we're going to edit it. So the way that we need to do that is, let's just double check, so click drag, that we are facing the right way. Viewpoint front, so we are. What we're going to do, switch to face select. We're going to select individual faces and unwrap them. So there is the corresponding UV. We're going to use transform widget, or the universal, which combines move, rotate and scale all in one widget. That will give us the widget tool, and this gives us the ability to, in one tool, to scale in a single direction. So if we click drag the edges, scale on multiples, if we click on the corners, rotate, and then translate, so that just moves us left, right, top, bottom. So it's all the controls are in one tool. So click drag. And what we want to do as well whilst we're here is UV, or before we go any further, that should be, so we want round to pixels and then corner. This used to be snap to pixels, so UV, round to pixels, or snap to pixels, corner. What we can find is that the pixels of the image act as a grid, because we're at such a small scale, and that means that we can use the widget and set up our individual UVs. So again, we're just highlighting individual faces in the 3D view on the mesh, and that highlights the corresponding UV, single UV, that corresponds to that selected face, and then we can just move that into position using the tool. That's inside. And the back. And then we've got the top, so let's just hide torso. That's the top. Double check the orientation, so this little indicator points forward, or should point forward. So red is the top, pale blue is the bottom. So that's the leg section. So the leg section of the image is on the left, the arms are on the right, the torso is in the middle, and the head is at the top. So we want the arm, so edit mode, object mode, select our object, back into edit mode, select the face. So that's the arm. That's the front. inside and back. Then red is the top. Make sure that's facing the right way. And blue is the bottom. So that's arms. Torso. Object mode, select. Edit mode. Front. Right. And back. Then got top. So that's the red. Turn that around. And the blue. Turn that around. That's the torso. And then we want the head. So object mode, we can exit and enter, well, exit. If we hide a mesh whilst we're in edit mode, the mode is still active and we can swap out of it, select a mesh and then go into edit mode, and the mesh will obviously still remain hidden, but we're no longer editing it. So left, front, right, back, so that's the front face. So top, that's the red, and then bottom. And because we've taken the time to do this, exit out of edit mode into object mode. Because we've taken the time to do this, we can go back into shading workspace. There's our character. We can click on the folder icon in our image node and load in the actual image that we might want to use. And that will replace it, and everything will be set up where it needs to be. So the top of the arms, the hands, or the bottom of the hands, the fingers, where the fingers would be, the feet, and so on. So whilst we're here actually using the outliner, let's rename these cubes to make it easier to see what we're doing. So double click m.arm, double click m.torso, double click the entry in the outliner m.leg, and the head, double click m.head, because we obviously need 2 arms, 2 legs, so we're going to duplicate and mirror the existing across the center point so that we have 2 arms and 2 legs. So back into layout, let's just save this before we do. So file, save as, version 4, save. And then to do this, you need to make sure that the cursor is at the center of the grid. So we've set this character up so that all the objects are relative to, they have been snapped to the grid, which means that center point, or the center line, goes straight up and down the center of our character. So both in both ways, so front to back, side to side. So we need to check that the cursor is at where it needs to be. So in the sidebar, we want to go into View, and we can check 3D cursor's location. And it is at 0, 0, 0, but if it was not, just click type. So let's say for the sake of argument it's up there. We can see the coordinates are different, so we want to change those coordinates. So it's now here, and then this last one, we'll drop it down to the avatar's feet, or the character's feet. So that's step 1, make sure the cursor is where it needs to be. Step 2, change the pivot point. At the moment it's on median, or median, which is the default. We want 3D cursor. So pivot point, 3D cursor. So we can see that the widget, so if we just go back to median point, right now it's focused on the leg. The widget will change its position to focus on the 3D cursor. That confirms that the switch has happened. That's what we want. So to mirror, this is a simple mirror. So all we're doing is selecting our mesh, object, duplicate objects. That will get us our duplicate. Press escape just to release, reset. Then what we want to do is object, mirror, X global in this case. So object, mirror, X global. That will flip it across the cursor as the pivot to the other side of the mesh. That's leg. Do the same thing for the arm. So object, duplicate, press escape to reset, object, mirror, X global. And that will flip it across the pivot. So the distance from the pivot determines where the duplicate is placed relative to that pivot. So in this case, it will automatically place our duplicate arm and leg where it needs to be relative to the center line. So we're almost done. Next step, now that we've mirrored those, is to make them real. What this means is that we make them relative to their current position. not their original position, which is on this side of the mesh. So if we select our mesh, the ones that we've just duplicated and mirrored, Object, Apply, Rotation and Scale. Object, Apply, Rotation and Scale. This will invert the meshes. We can't see this at the moment because we go down into our material and enable backface culling. The mesh will appear inside out because fixing the mesh in place relative to its actual position will invert the faces because the object was mirrored. To fix that, what we want, Edit Mode, select all, and then from the Mesh menu we want Normals, Flip. So we can use Normals, Flip, or Recalculate Outside. Both will do the same thing in this particular instance because the faces are all inverted. So we can use Flip, and that will revert, make the faces point the right way out, or select the leg, do the same process again, Object, Apply, Rotation and Scale. The leg inverts, so Object Mode, Edit Mode, select all, and then Mesh, and this time we'll use Recalculate Outside, so do the same thing as Flip. So Mesh, Normals, Recalculate Outside, and it does basically the same thing. So that now means that all our objects are facing the right way, they are orientated the right way, and they're positioned relative to the center line. So let's just go to Item, double check something. So we're checking object size, but we've also now got scale because we changed the size of our objects. We want to fix this now before we go any further. So we want scale XYZ, we want all of that to be 1. So we can see that on the side that we fixed, because it was inside out, they are already 1. So we want to do that to all the objects. So select Object, Apply, Rotation and Scale, Rotation and Scale, Rotation and Scale. We don't need to do it to the head because we didn't do anything to that. So that is our basic character from the point of view of meshes. And we can see that we are still, because of the rescaling the scene that we did, we are still relative to Blender's default system. So before we go any further, let's just save this. File, save as, number 5. The next thing to do will be to add the rig to this. So for that, what we can do is build the basic functionality of our avatar and then add the elements that will give us a more expressive character rig. So again, we want to ensure that the cursor is at the center point or the center line at the feet of the character. So again, we want to go into View, just double check the location. Location primarily. Rotation values don't necessarily do anything, but if we want, we can change those as well. So the cursor is at the feet, and what we want to do from here is add armature. Add armature. This will drop in an armature object that will be hidden because of the character's feet. So let's just hide those. Leg, leg, there is our armature. and it comprises a single bone. So what we're going to do is add bones to this armature. We're going to add a bone for the legs, the arms, the torso and the head. The easiest way to do this is just to make sure that the armature is selected. Object mode, edit mode. So we're going to edit the armature. Its appearance will change slightly. So we have a top and a tail and a body. So when we're selecting our bones, just click on the body and that will select the bone. So we're going to leave this one where it is as our root, so everything, once we add the bones, will be linked to this root, and this root bone will control the character overall. So select our bone, and what we're going to do, let's unhide the legs. I want to go into Object Properties. What we can do here, because we are working with the armature, which is hidden because we need to see the mesh so that we can position the bones, we want to enable in front. And this basically turns on the X-ray feature for that selected object. So view, viewpoint, front, and then all we do is select the bone, armature, duplicate, Shift D, and this will duplicate the selected bone. So when we are in object mode, we are dealing with an armature object. When we are in edit mode, we are dealing with an individual bone. Make sure the bone is selected, armature, duplicate. This will duplicate a bone. Escape to reset. We can use our widgets as we did with the mesh editing. Click, grab, hold Control and just snap that into place. Let's put that there. We can duplicate this bone. Escape, move that across. So what we have to do as well, because we had the widget snapped to the cursor from our previous editing, we need to swap that or switch that back to median so that it jumps to the element that we've got selected. Hold Control, snap that across. Armature, duplicate. Escape, move that to the leg, armature, duplicate, escape, move that across, and then we can use that one for the torso, and the head. So this gives us our initial positions. So we've got the arms, the legs, the torso, the head, and the root bone. So let's just save this. And then what we'll do is Object Data Properties, Viewport Display, and then enable names. So we can now see the names of the bones. We want to change these. So an easy way to do this is to use the outliner. So there is our armature object. We can expand that, expand the armature, and there are our bones listed. So select the bone, named bone. As with the meshes, double click. Let's just call this root. Select the bone, double click. Leg dot R. So that's the actual right side of the character. So when the character is rotated so that we're actually looking at it the way that the character would be, so that's the right leg. That's the left leg. Leg.L. And we can use the outliner itself to select the bone, or to double check and make sure that we are selecting the correct bone, and we're going to rename it. We can use the 3D view to select it. So bone, so that's arm.R. That distinguishes the .R and the .L is right and left. Arm.L. Head. And torso. And whilst we're here, we can update the meshes. So that's marm.r. So we need to do the same thing to them. marm.l. .l, double click, .r. So those are the bones, the basic bones for the skeletons set up, their initial position and their names. So what we need to do now, view, viewpoint front, we're still in edit mode. And we need to change the pivot point to individual origin. And what this will do is we need to rotate these bones so they are essentially aligned to the body part that they are supposed to or will eventually control. So if we select and use the rotate tool, when we click on and rotate the bone, it rotates around the individual origin or head of the bone. So hold Control, snap to the increments, rotational increments, snap. That just ensures that the bone is properly aligned to the grid. Legs, legs, and we can see in doing this that what we're actually doing is positioning the origins as the rotational point for the bones. Essentially, this is the ball and socket of the shoulder, the ball and socket of the hip. So we want the bones to be rotated to accommodate the way that we would expect the limbs to actually move. So we are, even though it's a very blocky basic character, we have the expectation that the character is going to move, it's going to articulate the way that we would expect a humanoid character to do that. So that is the basic rig setup. We don't need to do anything to the head. If we wanted to, we could move that bone down to the neck. So move that down. Similarly for the torso, so that it's controlling the entire block and it's pivoting on that origin point for both of these, whereas we need the shoulders and the hips for these. So that's our basic armature. Let's exit into object mode, take a quick look, and the character. So that's the basic setup in terms of the bones that we need. So let's just save this. File, save as, and we've got another restore point if we need to, because the next step is to now link the bones together. So the root bone is the control. So we can do one of two things here. We can either connect everything to the torso and then torso to root, so that everything is essentially functioning relative to the body, or we can connect everything straight down to root. Doing that, however, will result in all the parts, the components, acting independently of each other. So there'd be no relationship between the torso and the arms. They would move independently of each other. Typically then, we would want to use the torso as our sub-root and then link that to root as the root. So select the skeleton or the armature, back into edit mode, and then we're going to select the individual bones and link them to root. So for this we want to be in bone properties. We want relations, and that will give us this option parent, and we've got this little icon that we can click to set the parent from the bones that are listed. So this creates a hierarchy between the bones. So if we select torso, click on the list, we can set root as our parent, and that will link it, which is confirmed by the relationship line that we can see between the two. So root now controls torso, and we can test this if we go into pose mode. So edit mode to pose mode, select the root bone, press the R key, and we can see that torso moves with root, whereas the other bones don't, because there's no relationship between these bones and root or torso. So let's just press escape. Incidentally, if we accidentally pose the bone whilst we're doing this testing and setup, all we need to do is select the bone that was moved, pose, clear transform, all. Clear transform, all, and that will reset the bone. So leg to torso, so we select the leg, need to be in edit mode again, and from the parent list we want to select torso. That will create a relationship line between those two. Do the same thing again, torso. So now if we switch back into pose mode, select root, press the R key, so we now have those two bones controlled ultimately by root, or if we select torso, we have torso controlling the legs. What we're going to do is the same thing for all the other bones. Back into edit mode, arm, again from the list, torso, arm, torso, and then head, torso. So if we check the armature pose mode, what we have is selecting torso. That moves the character's main bones, representing each of the body parts, and then we have root that controls the entire armature. So, back into edit mode. So we can see the relationships. Arms to torso, head to torso, legs to torso, and then torso to root. So let's go back into object mode, and again save the file so we have a restore point. And then the next thing is to weight or link the meshes to the armature, because right now, as we saw when we moved the bones, none of the meshes moved with them. And this is where the names come into play. So because this is a relatively simple character, let's go back into object mode. The way that we do this is two things. One, select our mesh, modifier properties, add modifier, armature. That will drop in an armature instance, and in the object field we can click on the object selector and select armature, which is the name of the armature. Set that. If we go back into pose mode, press the R key, we still don't have the mesh moving with the object, but that's step one. We need to assign an armature object to each of the body parts, because this tells Blender that this particular armature is supposed to have influence and control over these objects. So we've got one object, armature, controlling another object, which are the meshes. So the second part is to select our meshes, object data properties for the mesh. We need to set up a vertex group. So we need to click on the plus button. That will create a default group called group. Double click, rename, and this needs to correspond. So this needs to correspond to the name that's associated with the bone. So in this case, arm.r. It's case sensitive. Go into edit mode for the mesh. Select all. And then we have these buttons that have appeared. We click on Assign. Click Assign, and then we can test this with Select and Deselect. And we should find that our mesh, the entire object, let's just go into wireframe for the moment, is selected. And what we'll find, if we switch back to object mode, select the armature, pose mode, if we now move that bone, the arm moves with it. So it's a twofold process. The armature modifier signifies the link between the two objects. So that's the armature object and the mesh object. And then the vertex group is what actually creates the controlling link, essentially, between the bone and the underlying structure of the mesh. So it's armature object type, mesh object type, and then bone element to mesh element. And all we have to do is repeat that for all the other parts. So object, new group, double click, arm.l, new group, leg.l, new group, leg.r, new group, torso, then new group, head. So that's the groups. Now we have to assign them to our meshes. So edit, select all, assign, deselect, just double check. Edit mode, select all, assign, object mode, edit mode, select all. We've already done that one. Deselect, select. Edit mode, select all, assign, deselect, select. Edit mode, select all, assign, deselect, select. Object mode, edit mode, select all, assign, and deselect. So what we should find now, select our armature, pose mode, that all the elements are controlled by their respective bones. So select the bone, press the R key for rotate, R key, we forgot to do that one, head, and that one, torso, and that one, and that one, and that one, because what we've forgotten to do is our modifier. So we've set up the vertex group, modifiers, add modifier, armature, 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 and armature. Now we should find that that works. So test again. That moves. That moves. That moves. Torso. That moves. That moves. That moves. And of course, root moves everything. And that is our basic, very basic rig. So we could do animations with this. But we're going to modify this to allow us to make more expressive animations. Let's just go into object mode and save this again before we go any further. So save as number 9. So now that we've got a rig for our character, if we take a closer look at it, so select, pose mode. So we're going to pose mode to pose the character and test the manipulation or the deformation of the meshes as we did before when we set it up. So if we select our bone and press the R key, we have rotation around the origin points for each of the specific bones. So we are positioning these when we're setting up the rig. As we discussed earlier, we are setting these up and positioning them relative to where the pivot should be for the element that's being manipulated. So for things like the arms and the legs, that's relatively straightforward to do because we are just positioning the bones so that the head is at the shoulders or the hips. But for things like the torso, where we have the same sort of rotational axis point, so that's our pivot point, when we rotate that, it rotates the entire character. Similarly for the root bone, which actually we want for the root bone. We want the root bone to do that because that controls the entire character. So if the animation has the character moving off grid, whatever the character is being moved for contextually, generally you wouldn't do it by manipulating the root bone, you would do it programmatically inside the game. The root bone doesn't move, but it gives us control over the entire avatar. So to change this behavior, we can add some constraints, and as the name implies, they constrain or restrict the behavior of the bones. And what that does is it makes it easier to do certain types of articulation of the character. And it'll all make sense once we start setting this up. But essentially that's what we want to be doing. So in essence, or for example, the way that we set the bones up going forward means that when we move the torso, the legs don't follow it the way that they currently do based on this very simplistic rig. So let's go back into object mode. To do this, we need to add a number of bones, and the number of bones depends on the degree of control that we want to attribute to the rig. So for example, we want to control the legs so that we pivot them around the hip joint, but we also want to do it in a way that controls their orientation. And we can do that by placing, with it being the legs, we can place a knee bone that locks the rotation and the manipulation of the bone so that it always points towards the knee. We can do the same for the arms with an elbow bone. So the elbow or the arm always points at the elbow. But there's a big caveat with that, in that because this is a very simple skeleton, it's got a minimal amount of bones. That might present issues with the articulation because of the limited number of bones that have been used. So we don't actually have additional bones, so there's no bend at the elbow, there's no bend at the knee, so we don't have a lower leg, we don't have a lower arm, we don't have a chest bone. So all these play into how the character will articulate, even with the extra bones, the extra bits that we're going to add in order to make this function a bit more expressively. So with all of that out of the way, that's the preface to this part of the rigging process. You need to be aware of the fact that the number of bones affect how well the character will articulate. And of course, the number of bones mean that we also then have to make changes to the mesh to accommodate the number of bones. So all of that has to be kept in mind with this next step. So what we're going to do is add a hand and a foot control bone, and then we're going to add a knee and an elbow, so this will be behind there, elbow bone. So select our armature. We need to be in edit mode as always because we are editing the bones of the armature. And we can use our existing bones. Just select armature, duplicate, so these will be connected to or linked to the bone, that's the original bone that's being duplicated. It'll carry across that relationship. So escape to reset, and then we'll use the widget just to move those. Holding Control just to snap to the grid. We'll move those back as the elbows, and then we'll duplicate those again. Escape, and we'll move those down to the hands. We can rotate them, so rotate widget. And it again will hold Control down to snap to the increments, but we're rotating again around the bone's origin points. So we can do that for the arms and the elbows. We can do that for the hands and the elbows. So shift click, point those backwards. We'll change their position later on once we've got everything set up. So same for the legs. duplicate, escape. This will be the feet, 90 degrees. So when we're rotating, we're watching the top left corner, which gives us our rotation values. Move those down. Duplicate those again for the knees. Just move those roughly into place. So now that we've added these, we need to rename them, because it's done what Blender normally does, which is append a numerical increment. So in the outliner, we can rename them, expanding the bones and the armature, so we can rename them in the outliner, or we can rename them in bone properties. So this is elbow dot R, elbow dot L. The advantage of using the outliner versus the bone properties is we have to select the bone in order to rename it, whereas in the outliner we can just double click. That will automatically select the bone. So that's hand R, double click, hand L, double click, foot dot R, double click, foot dot L, knee dot R, knee dot L. So that's what we've got so far. So this next bit, we need to change the relationships between the bones, and this, because of the limited number of bones that the root or the core armature has, this might seem counterintuitive, but this is what needs to be done in order to get this more expressive system working. So select the knee bones, and in bone properties, in parent, we need to change the relationship, so that needs to be connected to foot.r. And we can see the relationship line changes. So we've currently got this one going up to torso, and this one now goes down to foot. Left foot. And then we need to change the foot relationship and link that to root, not leg. This is where the counterintuitive element of this setup comes into place. So foot, root, foot, root, and then the same for the elbows. Elbow goes to the hand, and left elbow, again this is pointing at torso currently, but it needs to point at hand, and L. So if we just do a quick look, switch to pose mode. So if we select hand and move that bone, that will move the elbow bone, but it doesn't move anything else at the moment because arm is the bone that controls that. Same again, hand on this side, same for foot, and similarly it's the leg bone that actually controls the leg. But this is where these constraints, IK constraints or inverse kinematics, how this changes the relationship between the bones. The simplest one and the first one we can set up is the torso, and this is just a standard inverse kinematic. So we want to go into bone modifiers or bone constraints. So add bone constraint, and we want to add an inverse kinematic to this. This is a simple IK, so all we're going to do is change the bone length or the chain length. So this will include the torso bone. So if we just rotate that, at the moment it still maintains the original articulation. If we change the chain length, it'll still do the same thing, but it'll come into play later on. Do the same thing for the head. So select the head bone, add constraint IK. So if you press the G key and see how that moves, so we can see already that there's a difference in the behavior of the character. Set that to 1. That moves just the head. Set that to 2, and it includes the torso in its movement. So we're already changing the behavior of the armature. Now to lock the legs in place so that when we move either of these, they stay put more or less, we select our leg bone. We're still in bone constraints. Add IK, inverse kinematic. But this time we're going to change the target and the pole target. We can click on the object selector, select armature. So this is the armature that we're using, which is the character's armature. And the bone that we are targeting is the foot bone. So we're making a programmatic link between the leg bone and the foot bone. So select it from the bone object list, and we want foot.r, and that'll make the character go a little bit wonky because we now need to change the pole target, which is the armature again, and then the bone, which we are using as our orientation target. So the pole target is the thing that keeps the bone, or this chain, this IK, pointing in a particular direction. And that's going to be the knee. So we click on the bone list and select it, knee.r. We then change the chain length, make that 1, and we should find now that when we select the foot bone, press the G key, that now moves the leg. So we've effectively inverted the relationship between the bones. So the foot bone and the knee work in conjunction with leg to control the behavior of the leg. And if we just move the torso, so press the G key, we can see the difference between the two. The constraints that we've added to that leg essentially locks it loosely, it locks it in place, compared to the other leg, which doesn't have that constraint in place and moves the way that it did originally. So now that we've got that, we just need to repeat it on the opposite leg. So select the bone, bone constraints, add constraint, IK. We need to set the target object, which is the armature itself, and the bone that we are targeting with this constraint, which is the left foot in this instance. So bone list, foot left. That'll make the character go a little bit wonky. Need to set the pole target object, again, which is the armature, and then the bone, which is acting as the orientation target. That is our knee. It'll make the armature go a bit wonky again. Then we change the chain length to 1. So if we had more bones, so if we actually had a lower leg bone, we could change the chain length to 2 and it would do the same sort of thing. So the number of bones in the underlying skeleton affects how this is set up. So now that we've got that set up, we can press the G key and move our leg. But we want to do one other thing. If we look at the mesh, this leg has been rotated. So what we want to try and do here is adjust this by adjusting pole angle so that this rotates and is facing the right way. So this is the inside leg, so let's try -90. It's now on the outside, so let's try +90. So that's the right way around. Same for the opposite leg, so let's try -90 for this one. That's on the outside, so let's try +90. So that's now facing the right way. All that does is adjust the orientation of the mesh relative to the constraint that we've added to the bone. So now, torso, we can move the torso and the legs stay more or less put. Obviously, the more bones the armature has, the better the articulation. So we now need to repeat that for the arms. So arm, bone constraint, a constraint, IK, target, armature, bone, hand, R. That'll make it go wonky. Pole target, armature, bone, elbow, R. That'll make the armature go wonky. Then we set the chain length 1. So now we have the hand controlling the arm, and it stays more or less rotated with respect to the elbow. So as with the leg, we've inverted the relationship between the bones because of the inverse kinematic setup. So if we compare that to the opposite side, which isn't set up yet, that's still relying on the underlying bone. So repeat the process, select the arm, constraint, IK, armature, this is hand.L, makes the armature go wonky, pole target, armature, bone, elbow.L, makes the armature go wonky, increase the chain length, so now we can select the hand and move the arm. So if we now move the torso, everything moves okay, and same for the head. So we've got simple IK added to the head, which is just a bone chain. So the head's 2 bones, itself and the torso. The torso has the same simple IK, and it has itself as the chain member. And then we've got the IKs, or the constraints, added to the arms so that they are controlled by the hand, and then the foot controls the legs. But you'll note that we didn't need to add pole angle to the arms, but we did to the legs. So we may need to do some testing to make sure that the arms are rotated around the right way relative to the legs and vice versa, depending on what it is that you're animating. But that is our simple, more expressive rig. And if we want to control the rotation or the rotational point of the foot or the hands, because the elbow and the knee control the point at which the arm will start or the leg will start to rotate around the axis. There are complicated things that we can do to fix that, but the simple solution is just to go into edit mode and adjust the position of these so that they are less likely to be pulled into use. Because they don't essentially infringe on the object that's being articulated. There are still points at which they may rotate awkwardly. But that is a more expressive control rig, and we can change the behaviors depending on what our control bones are linked to. So for example, the hands currently follow the torso, but we could change those so that their parent is root. So we'll do this on one side, but leave the other side intact. Pose mode. The hand stays put compared to the other side, which means that it's reacting to the way that the character is being manipulated, whereas the other hand isn't, or isn't so much. So I'm going to do the same thing for that. So we change that to root. So the bones always need to be parented to something, and root is the last bone or the master bone of the entire armature. So any bone that isn't linked specifically to another part of the body, so root is the master bone, so any bone that's not linked to another bone should always generally be linked to root. So we change that back into pose mode, and then we now get the arms moving in a similar way to the legs. So that is a very simple way of using bone constraints or IK constraints to control the behavior of our armature and our character. And that now makes the process of animating certain types of animation much easier. So let's just save this. Save as. This is our restore point. So as a comparison, if we go back to the original, so this is what we had originally. Pose mode. So we're selecting torso, pressing the G key, that will move us. R key will rotate us. R key, G key, R key, move, rotate, move, rotate, move, rotate, move, and then of course root, move, rotate. This is a functional rig. We can animate with this, but it's a little more time consuming to work with because we have to select individual bones, pose them, and then create the animation that way. We have to do it individually. So for the torso, we would have to move these bones after the fact. Whereas with our bone constraints in place, we can now move the torso and the rig will do that for us. The legs stay more or less in place. Obviously, we would have to adjust the position of our bones relative to the animation that we were actually trying to create, but death pose. About to fall over. And that's as quick and as simple as it can be once this is in place. And that's why we do it. So the next step, now that we've got this, is to maybe create a simple animation. So let's just clear all of this. Select all, pose, clear transform, all. Make sure that we have our file save, just in case. And then we can do an animation. Before we do that though, we want to finish setting up the meshes for the character. And that means adding the outline, the Toon Outline. So for that, we want to drop back into object mode. And there are two ways that we can do this cheaply. And this is the key. We're doing this as a low-cost way to create the effect of the outline around the character. So the first one is to literally duplicate the meshes. So we duplicate each mesh, we invert them, and then assign a black material. What that will do is create the effect of an outline, because we're essentially looking at an inverted mesh. Again, it'll all make sense once we actually do it. So select a mesh. Let's just use the arms for now. We want to duplicate these, so object, duplicate. We'll get our duplicate, escape to reset, and then obviously in the outliner we have our instance, our duplicate instance of our original. So what we can do here, whilst we're here actually, is just rename this outline or out or something that identifies the mesh. So that's the mesh. Let's go into material properties, sort out the material. So it's already assigned, obviously, because it's been duplicated from the original. It's already got a material instance assigned to it. So what we can do here is click on the number button, which indicates the number of users this material has. We can click on that and it'll duplicate an instance. It'll create a unique instance based on the material that's currently assigned. Once it does that, we can then edit the material to assign the black color. So we remove the image and assign a black color to it. So click on the button. That creates a new instance, so note the user button has disappeared because this is now unique. So let's just call this outline. So again, it's carrying the same properties, so it's basically duplicated them across. I want to switch into shading workspace. There is our original image. So we can decouple this, disconnect it from principled BSDF. That will make it use the base color that's associated with principled BSDF. We can click on that and change it to black. So that's our black material. If we wanted to, we could replace this image clicking on the folder icon and loading in an actual black image. Or alternatively, if we don't have one, we can just delete the image node, add a new one, click on Create New, call this Outline. This doesn't need to be big, but we'll just make it 256 by 256. We'll use the color and then click OK, and then we can connect this to base color. So now it's using the color that's associated with the image node. Because what we can do then is go into UV editing, and there is our black image that we're using. We can edit this if we want. So view sidebar, because it's a generated image, so we'll make it the same proportion as the underlying character skin, like so. And then once we've got that, we can go into image, save as, outline PNG, disable compression, that's okay, save as image. And what that does, go back into shading, is it creates a physical image that's referenced in our image texture node that's now linked to base color. So if we wanted to, we could change this by loading in again another image. But once we've got that, back into layout mode, we need to edit the mesh. Let's just go into edit mode, make sure everything is selected, and then what we want to do, mesh normals flip. Mesh normals flip. That will invert the normals and make the mesh essentially disappear because it's currently exactly the same size as the original that it was duplicated from. So to change that, the easiest way is to use object mode and then our dimension properties. So we go into item and use dimension coordinates. So if we zoom in a little bit more, what we can do here is click type, let's try 0.8, so 4.8 meters. Same value on all axes, 4.8. Let's try 12.8. So there is our outline. We may need to remove or turn off the wireframe display that we set earlier. So we're in viewport overlays, just turn off wireframe, so we get a better sense of our outline. And because this is duplicated from the mesh that's already set up, we go into pose mode. That will track with our main body mesh. And it'll do the same thing for all of them once we get those set up. So the reason we want to use object mode to change the outline is that it's just easier to just type a value to make sure that the duplicate is the same size on all axes. So now that we've got our material set up, all we need to do is duplicate our other objects and assign the material and invert the meshes. So duplicate objects, escape, assign the material. So we're going to use the Browse Material button. There's our outline. Assign it. Edit mode. Select all. Mesh. Normals. Flip. Mesh. Normals. Flip. That inverts it. Back to object mode. Dimensions. 8.6, 4.6, 12.6. Again, test. That works fine. Arm. Object, duplicate, escape, assign the material, outline, edit mode, select all, mesh, flip, object mode, 0.6, 0.6, 0.6, test, and we can see how effective this very simple technique is, just duplicating the meshes and inverting them. Escape. Assign the material, edit, select all, invert or flip, object mode, 8.6, 8.6, 8.6, test. Legs, duplicate, escape, material, edit mode, select all, flip, object mode, 0.6, 0.6, 0.6, pose mode, object mode, select, duplicate, escape, material, edit mode, select all, flip, object mode, and the dimensions again for one last time. And then test. So we've now got our fully formed legacy style character with its Toon outline. Now obviously this is not perfect because of the way it's been put together, because we do still have some clipped areas that shouldn't be outlined if this were done as a post-process. So in-game this would actually be done as a post-process where the game calculates the silhouette and then draws an outline around it. But that's actually quite resource hungry, so a cheap way of doing it is just this. So this is one way. So let's just save this. File, save as. So the other way, so let's load in number 11. That's the one we had before, that's the clean one. So the alternative way to do this, adding the outline, is to use a solidify modifier. So we're back with our character before animation, object mode. So we select our meshes. We need our outline material. So create a new instance, new, rename this outline, give it a color. So we're just going to use base color, slider down to black, turn off specular, turn off roughness, scroll down to the bottom and enable backface culling. So we're essentially replicating the material that was assigned to the duplicated mesh objects. So that's our material. We want to go into modifier properties, add modifier, solidify. So add modifier, solidify. Click to assign. It won't necessarily do anything right now because we need to change the thickness. So this will be a negative value, which increases the size of our cube. So we can either click slide or type a value. So click, let's type 4. We want normals, flip. So this is doing what the mesh option did down at the bottom here when we were flipping the surfaces in edit mode. This does this for us. So it's inverted the mesh. And then what we want to do next is materials, material offset. We want to set that to 1 because 0 is essentially the legacy material that we can see at the moment, and 1 is the outline. So we're offsetting that reference. There is our black outline. And again, we just need to disable the viewport display of the wireframe. So viewport overlays. So we get a better sense of what this is doing. So we just need to replicate that. So add modifier, solidify. We used -4. Flip the normals and offset the material. What we need to do whenever we do this, because we've created a new instance, we need to add the outline material. So that's that one done. So same again, outline. Might as well do all the objects. So that's all the materials assigned. We should then be able to go back into modifiers and just set up the modifier. Solidify minus 0.4, normals, flip, material, offset, modifier, solidify minus 0.4, so we're typing that, flip, material, minus 0.4, flip, offset, solidify, minus 0.4, flip, material, offset, and there is our alternative outline. Now obviously it has the same issues because it's not being post-processed. It's another cheap way of doing the same thing, but we've assigned them to our individual objects because we've kept the arms, well, the body parts, as separate objects. We could join all the objects together into a single mesh, and it would then just mean that we're creating a single instance of our solidify and a single instance of the material that's then assigned to the overall object. And it's the same for duplicating the meshes manually. So it's either or. We can either apply the effect to the individual mesh objects that we kept separate, or we can join all these meshes together and it won't affect the rigging. Now of course we can test the rigging and it works perfectly fine. So that's our Toon shader outline. So let's just save this, and then we can do a simple animation. Save as. But that's two simple ways of creating an outline on our meshes. One is physically or manually duplicating our objects and inverting the meshes, and the other is using a modifier. So with that done, let's create an animation. So what we might want to do first is create a pose rather than necessarily a complicated animation, so that we can test the rig and the constraints, make sure that they are working the way that we expect them to. To make the process easier, what we want to do first is enable and edit the auto insert feature. So we want to enable auto insert in the timeline header. That's step one. Then in keying, we need to set the active keying set. So this is the data, or the type of data, that's going to be captured whenever the keyframe is inserted into the timeline. Click on the pair of keys, and typically this is going to be location, rotation, or location, rotation, and scale data, depending on the type of animation that's being created. So in this instance, we want to set location, rotation, and scale. So select the set. And then we need to make sure that the type of data that is being captured is locked to a keyframe. And that's it. Now that we've got that done, what we can do next is expand the timeline. So mouse over the border, click, drag up, just increase the size of that. And then we're going to switch from the timeline editor to the dope sheet. And then from the dope sheet editor to the action editor. This is where we'll create the sequence. So that changes the timeline. So this is where our sequence appears, or our sequence will be editable. And then when we insert keyframes, when we move a bone, a keyframe marker, that's those orange squares that we set previously, one of those will appear relative to the bone that's being posed. So it'll all make sense again when we do it. So let's make a pose where the avatar is picking something up. So we're going to use the widgets to manipulate the bones. So we want to rotate, or we can use our shortcut keys G to grab, and that will activate the inverse kinematic that we've got set up. So pose, and there we have our keyframe. There's one per channel, i.e. one per bone. So if we expand that, we've got our torso bone. Grab the hand, press the G key, grab the head bone, tilt that down, or we could press the G key and move that down as a group. So this is where the IKs come into play, because if we select and move the head bone using the G key, so that's into auto manipulate, it manipulates the bone in all directions, it will affect the head bone and the torso bone, and everything else will move correspondingly with that bone and the bone chain. So that's our bone chain. So set up the balance. Let's do the leg, so they're reaching down, and so we can see that we've got a marker for the bones that we've set, but we can only see the selected bone that we're editing. We want to see all the bones and the corresponding channels listed. So for that we want to disable this option, only show selected. So now we can see all the channels that we are adding a pose to. So if we want to move this bone backwards a little bit, but currently the IK that we set up there doesn't permit that. It only rotates that bone. So, and this is why we do a simple pose to double check. So we go back into bone constraints. We need to double check the manipulation or the articulation of the bones before we do any complex animations or complex poses. So we can do one of two things here. We can either reduce the chain length to 0, and that will essentially root the bone to root, or we can set it to 2, which basically does the same thing. But the problem with setting this up is that because it's linked it to the root bone, it means that the root bone moves. And generally speaking, we don't want that to be the case. We want that to stay static. So what we can do here is pop back into edit mode. That'll reset the skeleton, obviously, because we're in edit mode, so it goes back to the default pose. Select the root bone, duplicate it, escape to reset. We've now got an extra bone. Double click to rename. Let's call this master. So what we want to do now is change the relationships between torso. So we need to go into bone properties to be parented to master instead of root, and then master parented to root. And this shouldn't change the characteristics of the rig. So if we go back into pose mode, we should still find that the armature moves relative to the IK using two bones, with torso moving master instead of root. So this basically means that root will always stay put. It won't move or articulate. So what we can do now is just move that backwards a little bit. So the character is off balance slightly. And we can see that as we move, well, this torso bone in particular, as we move that bone, the IKs that we set up soft lock the limbs in place. They're essentially tracking a position rather than being fixed to it. So let's call that our pose. Go to frame 30, just reset. So select all, pose, clear transform, all. Pose, clear transform, all. That will reset and it'll auto drop in a keyframe for the corresponding bones. So what we want to do is actually invert these two poses. So what we can do is Alt click on the first frame, so this first set of keyframes, press the G key, move that to frame 60, Alt click the frames at frame 30, move that to frame 1, do the same thing again, frame 30, and then what we can also do is we've got a start point, a midpoint, and then we want to return back to 0. So what we can do here is two things. We can either Alt click the keyframes at frame 1 and duplicate them. So Shift D, duplicate. So key, duplicate. That will create a duplicate, and then we can move those and position them at frame 60. So that now means we've got a start, middle, end. Or to delete those, what we can do is select all the bones, select all, pose, copy pose. So pose, copy pose. Move the keyframe marker or timeline slider to frame 60. Pose, paste pose. Pose, paste pose. That will paste the pose that was copied at frame 1 to frame 60. Let's rename this. So let's just call this pickup dot action. Don't necessarily need the dot action, but it just clarifies the data in terms of what it is that we're looking at when we export, or if we export this to a third-party app. So that is our simple sequence. And that just tested our rig setup, because as we saw, because we needed the torso bone to move independently of the root bone, but we still needed the IK so that we get the effect of being able to manipulate all the bones as a group. We needed to add an extra bone into the skeleton, and we did that by simply dropping back into edit mode, duplicating the root bone. So let's just select it in the outliner, duplicating the root bone, creating a master that torso then links to, which then links to the root bone. So it's creating a hierarchy of articulation, but we don't want to make it too complicated. So that is our first animation. More or less it's a pose. So let's create another one. Before we do, make sure to click the shield icon. That creates a fake user for this action so that we don't lose it. And then click on the new sequence button. That'll duplicate the sequence that was active. Let's rename this idle.action. And then what we can do, so we'll keep our start and end, and we'll just get rid of or override the middle frame. So we can do that by resetting the pose. So select all, clear transform all, or we can just delete it. Click delete keyframes. So let's do a breathing. So it's going to go forward or backwards. Yeah, that looks a little weird, so we'll go backwards. And this is how we create a simple breathing cycle. But what we can also do move that forward a little bit. Oops, that looks a little suggestive, so let's move it backwards. Make sure to use our viewports to help with the posing. That looks a little weird from the side, so and what we can also do, even though we set up the IKs on the hands so that they articulate the arms, we still can move the arm bones using the arms that we set up. Let's just undo that. So the shoulders shrug as if the character is breathing. So that's a simple idle animation. Let's just save the file. File, save as 14. So that's an idle animation. So we can see how quickly, taking the time to set all of these constraints and IKs up, we can see how quickly that allows the creation of, or allows for the creation of, animated sequences. because we're not necessarily having to fight as we might do. Oops, let's enable the shield. We're not having to fight as we might do with the character and the skeleton absent all of these constraints. So we would have to move individual bones, and it would take much longer to do that with the original skeleton. So let's do another one. Switch back to idle. So duplicate. Let's call this walk.action. So again, we'll just keep the first and the last and then get rid of the middle. So Alt-click to make sure we've got all the frames. Key, delete keyframes, delete keyframes. So leg out, leg back, view right. That looks okay from the side. So we'll do the arms. These need to be the opposite direction of the legs. So that's frame 1. So let's just do a quick invert. So frame 30. So again, we copy. So select all, pose, copy, frame 60, paste, and then we have the rudimentary walk cycle. But we can actually make this a little bit more interesting because twist, so we want to reset that bone. Twist. So copy. So select those two bones. Pose. Copy. So we don't have to copy all bones, we can copy selected bones. Pose, paste, pose. So the character now slightly twists. View top. Check the head bone. If we can't select it in the 3D view, we can use the channel selector, or we can use the outliner. Pose, root, master, torso, head. Let's make sure that's pointing forwards. Pose, copy, frame 1, pose, paste. And that just straightens the head. Might be a little bit too straight, but that is our walk cycle. So if we go into output properties, we can set the duration or the length of our sequence. At the moment end is 250. Let's set it to 60. and then press the space bar, we can see our sequence loops, although very slowly. So we might want to change the frame rate press spacebar again. That makes it speed up a little bit. But remember, that's 30 frames per second. So right now this sequence is 2 seconds long. So Alt click, press G, move that to about 15. Alt click, press G, move that to 30. Change the end to 30, and then press spacebar. There we have our quicker animation. Obviously there's a lot more that can be done with it. For example, frame 1. Let's just tilt it. So a slightly odd walk. So copy that bone, pose, copy, frame 30, pose, paste. So it's doing a jive walk now, so spacebar. Obviously, given the type of character, the expressiveness in terms of what moves is limited, but we can still get something quite interesting. So that is our rig, our IKs, our constraints, set up and used for our animated sequence. So overall, that is creating our slightly more expressive character with Toon shaded outline, constraint rigged skeleton, animated. So of course save the file, and that's basically the project complete. Obviously, depending on what this was for, you would create a set of animations, a set of sequences, and then export it if it was to be used in an external third-party app. But that is our character set up and animated.